right, everybody. Welcome to our third annual Tech Talks. Our first guest speaker is Greg Nelson. Greg Nelson is a mechanical engineer with a BS degree from University of California, Davis. Since 2002, he has been working at Portland General Electric, helping customers implement energy efficiency projects. Prior to coming to Portland General Electric, he designed heating, ventilation, and air conditioning systems and plumbing systems for commercial and industrial facilities located across the United States. After spending most of his life living in suburbs and downtown condominiums, Greg and his family now live on a 2-acre farm on the east side of Multnomah County. Ask him about his recent experience raising chickens, ducks, and goats. Greg's weekend hobbies include air-powered rocket launchers and welding. He's way better at the former than the latter. He also recently completed construction of a wood-fired pizza oven and a small-scale aquaponics system. Greg is a proud owner and daily driver of an electric vehicle. Thank you, Greg.
Okay, I got to tell you first off that the last time I was on a stage like this, I was in high school and I was in a play, Romeo and Juliet. I was Paris, and that afforded me the opportunity to die horribly on stage. So hopefully I don't do that today. But I'll get my presentation going. And when I say die horribly, I mean I was a horrible actor. So I figured I'd start by starting with my high school career. I knew early on that I liked math, I liked science, and I liked solving problems. So that kind of pointed me to the idea that I should probably study engineering in college. And I liked physics the most, so that pointed me towards mechanical engineering. How many have applied to colleges in this room, just by show of hands? Okay, it's a fun process, right? I applied to 3 different schools. School A was a school that I thought I had very little chance of getting into. School B, I thought I had a pretty good chance, and then School C, I knew I could get into easy. So I sent in my applications, and I waited for the response. I got 2 rejections. I really didn't want to go to School C. Not that School C was bad, but it had a reputation as a party school, and I wanted to focus on studying. So I thought, well, I better regroup. So my first applications, I said I wanted to be a mechanical engineer, and that's what the programs I tried to apply to. So I decided, well, I'll reapply to School B, and I actually applied to study environmental toxicology. And lo and behold, School B accepted me. They just didn't have room in their engineering program. So I went to that school. I took the classes to become an environmental toxicologist, which, as luck would have it, were very similar to engineering courses. A lot of science, a lot of math. But within a year or so of college, I decided, well, I'm going to reapply to the College of Engineering, and I got in. So that's kind of the college years. In my early 20s and early 30s, I worked, as you heard, as a consulting engineer, designing heating and cooling systems for commercial buildings. That gave me the opportunity to work with architects, and so the architects are in charge of designing the layout of a building, and then the engineers come in, like myself and like the civil engineers, to make that building function well. The civil engineers will design the structure, the mechanical engineers will design the heating systems and the plumbing systems. And in that course of work, I had an opportunity to learn about energy codes and energy savings opportunities. You know, as a mechanical engineer, you're figuring out how much insulation to put in the walls, how much should you invest in efficient windows and things of that nature, and efficient heating and cooling systems. And in that process, I also began to learn that I like to do other things outside of work. I actually was a snowboard instructor for a while, and that kind of led me on my next career path, I thought, well, I can continue working for someone else, or I can go out on my own and start my own business, and maybe that'll give me some more free time to do the fun things on the weekends. And so I did that for a while. I had my own business, and it is true, you can make your own time when you have your own business. You can prioritize different things for yourself. But I kind of struggled with the lack of a paycheck. So I then decided that, well, maybe I should get back and work again for a company that, had their own people thinking about where the trajectory of the company should be, and I could just focus on engineering. So that's what led me to PGE, and I've been there for 15 years. I've enjoyed the work that I've done. I've been able to work on efficiency projects at schools. I've been able to work on construction projects as varied as prisons and ice skating rinks, and you name it, I probably worked on it. So that was fun. And but the bulk of my time at PGE, I've been working with industrial-sized customers on energy efficiency projects. So here are some examples of some of the equipment that you might see in an industrial facility. Specifically, this is for industrial refrigeration. Up there on the top right-hand side is a compressor that compresses refrigerant so that it can be evaporated in an evaporator, which is in the lower left-hand side. And then you have a condenser that takes that evaporated refrigerant and condenses it back into a liquid. And then the whole process repeats itself. And so all this equipment allows stores like Winco and Safeway to store mass quantities of food in one location and then distribute it to their stores. And some of the other more interesting or interesting customers that I've had a chance to work with are high-tech customers. They're designing microchips that go into phones and things of that nature. I've also worked with what I would consider, and many would consider, are low-tech industries. Maybe there's a farmer that needs to pump water out to a field and determine the best way to get that water out there in an efficient manner. I've been able to work with those types of customers as well. But part of my discussion I wanted to move into is where can my career go from here? And kind of more specifically, how can it apply to somebody just getting into engineering or a technical field? So that kind of led me to put some thoughts down, and I got this picture from PGE's website. Currently, PGE generates power that they distribute to customers, and 15% of that power generation is coming from renewable sources like wind, clean hydro, and solar. By 2025, we're committed to make that 27% renewable energy. And then by 2030, it's 35%. By 2040, it's 50%. And it's a great goal. It's not necessarily as easy as it may seem. You can't just continue to build new wind farms or put in new solar because of the effects that it has on the system. Here is an example of electricity generation provided by Bonneville Power Administration. They help distribute energy to small utilities, and they actually sell power to PGE at times as well. So at the very top of the graph, you've got the total energy, total power being generated for the grid. The bottom portion, the brown section, that's representing the power that's coming from your traditional gas-fired, coal-fired power plants. The green section is coming from wind projects, and the blue section is coming from hydroelectric. So this is, again, is Bonneville Power Administration's profile. They've got a lot of dams in their network, so they can get a lot of energy from the water, basically. But does anybody want to offer up a problem that they see here with integrating more and more renewable resources into the mix? How flat is the profile of a renewable resource? Is it flat? By show of hands, is it flat? Or is it pretty bumpy? Bumpy? Yeah, and it's somewhat unpredictable. Like with solar, you know when the sun's going to shine, and when the sun shines, you get electricity out of it. But there's also cloudy days. There's the nighttime. In the case of wind, the wind can come in the middle of the night when you don't necessarily need that energy. And so engineers in the future working for utilities are going to be blessed with this problem to solve. How do you smooth out the peaks associated with renewable energy and do it in a cost-effective manner? Because that's the other side of the equation, right? In order to be sustainable, you need to not only help the environment, but you need to do it in a manner that allows you to continue to make progress into the future. I have to tell you that that's the bulk of my presentation, so I was hoping that there might be a couple of questions out there today. Okay, I work for the local utility. You don't want to ask any questions about energy and where it comes from, where it goes? How about this? You've seen those wind turbines out there, right? Spinning away. How big might those objects be? Just by show of hands, are the individual blades 50 feet long? Anyone want to speculate that? Okay. How about 100 feet long? They're actually, some of them on the biggest ones, they're about 200 feet long. So that's just the blade. And so you're talking about a big tower out there in the middle of a field. So that's another aspect of renewable energy that, oh yeah. PGE has studies, and I appreciate the question, I'll repeat it here. The question was, how many birds get killed by the spinning turbines? And it's not zero. And so what PGE does is we keep track of the various bird kills and document them. And so we try to look for trends, we try to look for ways to decrease that number. And one of the struggles there, though, which maybe means we need more biologists out there, is we got to determine, you know, are we getting all these birds, or are some predators getting them before we can find them? We try to do our best job to track down the problems, and but so that I appreciate that question very much.
You said that a lot of the wind energy can come during the. You said that a lot of the wind energy can come during the night when it's not necessary. How come you can't store it and put it back into the grid when it is necessary?
Mm-hmm. Again, that's a great question. And the answer is you can store it, right? There's batteries, there's other technologies that you can use, but those are currently not they're not available in utility scale. PGE has a relatively small battery system down in Salem where we're experimenting with storing energy. And so that's not only to store energy from wind and other renewable resources, but it's also there in case a power outage goes out, you can then discharge from the battery. So it's in the works, and it's potentially something that someone in a technical field could help us work on that problem. Thank you. These are all great questions. I'd love to have more. Otherwise, I'm going to... Oh, yeah.
You said green hydroelectric or dirty hydroelectric?
And again, I'm not the best presenter. So clean hydro just means it's been certified. I better repeat that question. So the question was, I said clean hydro. And is there dirty hydro? So there's different scales of cleanliness and different ways you can rate things, but we've gone through the process, PGE has gone through the process of certifying their hydroelectric facilities. And what that entails is we're making sure that there's fish passage, and we're managing the water resources, the temperature, discharge, and all these factors that can be potential downsides of hydroelectric projects. And we try to mitigate those problems that they can create. I'm sorry? That is an awesome question. The question was, how fast does the wind need to blow to move the turbines? And I don't know if you have had a chance to look at them closely, but they don't spin very fast, right? So don't quote me on this, but it's somewhere in the range of 20 miles per hour. And so there's a kind of a sweet spot. I think above 60, we don't really want that either, because you can potentially damage the turbine too. So that's an interesting conundrum. You can have a lot of wind blowing, but you may have to shut off your wind turbines in an extreme wind event, or even a powerful wind event to prevent them from breaking down. So even though the wind's blowing, you're not necessarily generating electricity. These are all great questions. So the question was, is geothermal viable? And I would definitely say yes. It's one of the renewable resources that I believe Oregon is looking into, not just PGE, but other utilities as well. One of the problems that need to be mitigated in that technology is, yeah, you can pull heat out of the ground, potentially even in natural steam pockets, but oftentimes that water has a chemical makeup that will erode pipes and break down pumps. And so currently there's not too many cost-effective methods of extracting that energy in Oregon, but it's definitely something that's being looked into. I love all these questions. Thank you very much. Any more? Okay, so should I go into how power is being generated? Actually, I'm about up with my time too, right?
Yeah, about 5 minutes.
Okay, so how is power generated? Anybody have the physics background on that in the back?
Power is energy over time, right?
Yeah. So yeah, power, I guess that's a good thing to touch on. Power is measured in watts. Energy, at least on, and I'm talking in electrical terms, power is measured in watts, and energy is measured as power times whatever time it is applied to. So if you're averaging 1 kilowatt for 1 hour, that's 1 kilowatt hour of energy that you're producing. And so most power generation on the utility side is being generated by spinning magnets, basically. So if you spin a magnet, you can induce a current in a wire. And so typically we're spinning magnets to create this electrical source. As a mechanical engineer, I'm not too adept at describing what happens to those electrons as they move through our wires, but I'd be happy to field any questions that you might have in that regard. How about solar? How does solar work? We're not spinning magnets with solar. So solar involves a chemical process where you take a relatively inert substance and you make one want to have electrons and one to have electrons to give up, and you have a kind of a shield layer in between the two. The sun hits it and it can provide enough energy to break those electrons loose and force them through a circuit. And electrons moving is what helps us make the lights come on.
Do solar panels like go out of juice eventually? You're saying it's chemical things, and eventually a solar panel will just run less and less?
No, and that's a great question though. But so the question was, do solar panels eventually run out of juice? And In mechanical terms, I would say no. But there's a natural degradation over time, right? You can maybe develop a film over the top surface, which then lets less light through, which can then effectively reduce the capacity that you can generate. Well, again, thank you for all your questions, because I obviously didn't bring enough material to keep myself occupied up here on stage. So I very much appreciate it. Any more before I take off? Well, thank you very much.
Thank you.